Hey, what's up guys, it's Carter here. We all know about the ideal gas law, PV equals nRT, and we also know that R is a constant, meaning that it is one specific set value. Normally a textbook will just tell you what the value of R is, and that'll be the end of it. But in this lab, we're going to find out what R is all on our own by taking 6 measurements about a hydrogen gas sample we produce by reacting magnesium metal with hydrochloric acid. We will use the mass of the magnesium and some stoichiometry to get us the number of moles N for our final gas sample. We'll then use the temperature of the water in our beaker as a proxy for the temperature of the gas. Using a eudiometer, we can measure the volume of the gas pretty easily. And lastly, we will determine the pressure of the gas by measuring the height of the column above the surface, the barometric pressure, and the vapor pressure of water at our specific temperature. So remember that you need 6 measurements altogether. Let's get started. Our first step is to fill a 400 milliliter beaker about 3/4 of the way full with tap water. Next, we're going to find the mass of a magnesium strip to the nearest 0.0001 grams. Getting a reading with this amount of detail, 4 significant figures, will require using a special balance called an analytical balance. First, turn the balance on and place a small sheet of paper in the balance. Then press tare and place your small magnesium strip on the paper and record your measurement. Pretty simple. So our next step is where people start to get a little confused. Fortunately, we can watch each step on the video, so if the written instructions are confusing, don't worry. That's what the video is for. Step 3 says to roll the magnesium into a spiral and use a copper wire to create a cage around the magnesium. What does that mean? We'll show you. So here we go. Mr. Falk is filling in for Taz today. Here he rolls the magnesium into a spiral. And now he is threading the copper wire through the magnesium and wrapping it around to make a cage. Next, we want to pour about 10 milliliters of 6 molar HCl into a eudiometer tube, which is a big tube for measuring gas. Now, 6 molar HCl is some pretty strong stuff, so make sure you put on your gloves. To safely get 10 milliliters, we're going to use a Zipette bottle top dispenser that your teacher will help you with. The first step is to remove the top, pull up, and then slowly press down. Remember to replace the top when you're done. So now that we have our 10 milliliters, pour it carefully into the eudiometer. Next, fill the rest of the tube with distilled water, leaving yourself what I think is a pretty cool looking meniscus that protrudes at the top. Now you're going to thread the copper wire you wrapped around the magnesium through a stopper. Make sure you leave about an inch between the magnesium and the stopper, so your final should look like this. Next, you're going to place the stopper in the tube and then quickly invert the tube so the stopper is submerged in the beaker you filled with the tap water. You want the stopper about an inch from the bottom of the beaker. Make sure you wear gloves when you do this, and use your finger to cover the stopper of the eudiometer so nothing leaks. If you see an air bubble right after you invert the tube, you need to empty the tube, rinse with distilled water, and try again. Now the reaction is underway at full speed. Notice that the water level rises. Once the hydrogen bubbles stop forming, record the volume of the hydrogen gas to the nearest 0.1 milliliter. That part's pretty straightforward. For step 10, you need to measure the height of the column of solution from the surface of the beaker to the meniscus. So carefully line up the ruler so it just touches the surface, and measure how high the column goes. Use a thermometer to measure the temperature of the water in the beaker. Here we removed the eudiometer to make it easier to see on film, but for you guys, the eudiometer will still be there. Carefully look at the line and record the temperature to the nearest 0.2 degrees Celsius. At this point, you should have taken 4 readings. 1, the mass of the magnesium, 2, the volume of the H2 gas, 3, the height of the column, and 4, the temperature of the water. Once you know you have 4 measurements, unplug the stopper and rinse everything down the drain. Make sure you wipe down your station. To make our final 2 measurements, we actually need to move into another room. Listen to your teacher on where to go to find the barometric pressure. Some teachers might just tell you what it is, but if you need to find it yourself, open the doors and adjust the knob until the ruler lines up with the column. Then use the markings on the right to get your measurement. So here our reading is 75.4 centimeters of mercury. Remember that you still need to convert this measurement to millimeters of mercury. Lastly, use a table to determine the vapor pressure of water at our specific temperature. If our temperature was 22.6 degrees Celsius, first find the row that says 22 and then line that up with the 0.6 column. The number there is your vapor pressure in millimeters of mercury. We finally have all 6 of our measurements, so we now have enough information to solve for R. Listen to your teacher for any other instructions. Great work on this lab. Good luck, guys.